All right, on number one, we need to start by writing a function to model this situation. So on the day a video was posted, 5 people watched the video. 5 is my initial amount. And then the next day, the number of viewers doubled. And we're going to assume that the number of viewers doubles every day. So that means my growth factor is 2. So my function, I can say, would just be 5, my initial amount, times my growth factor of 2 to whatever variable I want to use, x or d for days or t for time. So now, if I want to figure out on what day 640 people saw the video, well, I need to figure out 5 times 2 to what power equals 640. So to do that, I can use the table feature on the calculator. So I already have this function typed into y equals 5 times 2 to the x power. So now if I go to my table, I can see that 640 shows up after 7 days, right? So this question mark here would really be a 7. 5 times 2 to the 7th power equals 640. So my answer is 7 days. And I mean, this is the explanation for that. Same thing here. How many days have passed for 2,560 people to watch the video? Well, if I go back to my calculator, I see that that value shows up here after 9 days. So I can say that 5 times 2 to the 9th power equals 2,560, therefore 9 days. Now, for the last part, we want to figure out when more than 20,000 people have seen the video. We just want to round to the nearest day here. After approximately how many days will this occur? We don't have to get super specific for this one, but if I scroll down a little bit, the first time that we get above 20,000 is right here, after 12 days, right? So I can say that 5 times 2 to the 12th power is 20,480. So after approximately 12 days, we'll get to 20,000 people. On the second question, we are given a function to model this situation. Right? A bank account is modeled by 1,500 times 1.09 to the t power. Now, if I want to analyze this function, this means that I'm starting with a balance of $1,500 and I am increasing by 9% per year. That's how I would interpret this situation. So we want to figure out how many years it's going to take for the account to double. And again, we don't have to be super specific. We can just round to the nearest whole year. So if my initial balance is 1,500, I'm trying to figure out when I get to 3,000, right? So I'm trying to figure out 1,500 times 1.09 to the t power, when that equals 3,000. Again, I can use the table feature on my calculator here. So if I put this function in, so if I go back to y equals and put in 1,500 times 1.09 to the x power, remember we have to use the variable of x on the calculator, and I go back to my table, so second graph, I can see that the first time I get above 3,000 is after 9 years, but it just asks about how many years will it take to double. So this is the value that's closest to 3,000, right? So I'm going to say after 8 years. Right, so I can say that 1,500 times 1.09 to the 8th power was $2,988.84. So I'll say 8 years is my answer for this one. The next question, we are just looking to figure out what value should go in the question mark. Now, to do this, it might make sense to think about rewriting each of these in exponential form. So remember, to go from a log to exponential, the base of the log becomes the base of the exponential. So this would become 10 to the question mark power equals 10. Well, 10 to the first power equals 10. So here, my missing value is 1. For this one, again, 10 to the question mark power equals 10,000. Well, we've talked about when we have 10 to a power, we're essentially just counting zeros, right? So I can say 10 to the fourth power equals 10,000. Now this one, the question mark is in a different spot, but I still want to think about rewriting this as an exponential. So this one would become 10 to the seventh power equals my question mark. And 10 to the seventh power, right, it's basically just a 1 followed by 7 zeros. So here, my missing value is 10 million. On the next one, we actually want to write out how we would say this expression in words, right? So the way that I would say this is log base 3 of 81. Okay, now I guess we don't necessarily have to write out the numbers. I could say log base 3 of 81. That would be perfectly fine. Now, what this means is 3 to some power, right? If I'm thinking about, what this would equal, 3 to some power equals 81. So what is the value of this expression? 3 to what power equals 81? Right? Well, this one works out nice that 3 to the fourth power equals 81. So I can say log base 3 of 81 equals 4 because three to the fourth power equals 81. On the next one, I just want to rewrite this first one in exponential form. So remember, I can just say the base of the log becomes the base of the exponential, and then whatever the log is equal to is my exponent. So this one would be 2 to the fourth power equals 16. Now, when you're rewriting things like this, if you're questioning whether you did it correctly, just make sure that your statement is true. Make sure that 2 to the fourth power does in fact equal 16. On this one, if I want to start with an exponential and rewrite it as a log, remember, the base of the exponential becomes the base of the log. So this will be log base 5 of 1 over 25 equals -2. The log is always equal to the exponent. The last one here, explain why log base 2 of 1 equals 0. Well, that's because I can rewrite this and say 2 to the 0 power equals 1. That's my explanation, right? Just showing that in exponential form. The last question here on the review is asking me to give an exact and an approximate answer to each of these equations. So for the exact, that's where I want to just write this out as a log. I'm essentially just rewriting this exponential in logarithmic form. So I can say that if I want to rewrite this as a log, I would say log base 4 of 47 equals w, equals my exponent. Now, if I want the approximate value, I can put this into the calculator. Now, remember, on the calculator, to put in logs, I am going to the math menu and then scrolling up to log base. This lets me put in any log that I want. So log base 4 of 47. And it says round to 4 decimal places. So if I round this to 4 decimal places, that would be 2.7773. All right. Now, remember, just to reiterate what this means that 4 to the log base 4 of 47 power equals 47, right? And this means then that 4 to the 2.7773 power equals 47, right? This log base 4 of 47 is my exact answer. This is my approximation. This is what log base 4 of 47 would equal if I put that in the calculator and got a decimal approximation. So we just want to do the same thing for the next 3 problems, right? Start by rewriting it as a log. So the base of the exponential will be the base of the log. So this will be log base 12 of 1/4 equals x. So that's my exact answer. My approximate answer then, well, I can just put log base 12 of 1/4 into the calculator. So math, scroll up to log base. So log base 12 of 1/4 gets me negative 0.5579 if I round that to 4 decimal places. All right, and again, remember what that means is 12 to this power would equal 1/4. Or I could also say 12 to the log base 12 of 1/4 power equals 1/4, or 12 to the negative 0.5579 power equals 1/4. Same thing on the next one. Rewrite this as a log first, so the base of the exponential becomes the base of the log. So I'll have log base 1/3 of 81 equals y. So that means 1/3 to the log base 1/3 of 81 power equals 81. And if I want the value of that, right, I can put this in the calculator. So math, scroll up to log base of 1/3 of 81. Oops. And this is an exact value, right? This is just -4. So I don't have to round this at all, right? This one is just equal to -4. And again, what that means then is 1/3 to the -4th power equals 81. The very last one, same thing. Rewrite this as a log. So log base 5 of 832 equals z. All right, so again, what that means is 5 to the log base 5 of 832 power equals 832. And then we can get a decimal approximation for this in the calculator. So I can say math log base 5 of 832. And that comes out to 4.1778 if I round to 4 decimal places. And what that means is 5 to the 4.1778 power equals 832.